All these worlds are yours. Except Europa, attempt no landing there. These words appeared on cinema screens and book pages over 40 years ago. Arthur C. Clarke, the man who predicted satellite communication and the internet, left us this message in 2010 Odyssey 2. For an entire generation, this didn't sound like science fiction. It sounded like a prohibition, like an ancient taboo inscribed on the border of the unknown, as if someone or something in the black abyss of space had drawn a red line that humanity must not cross. We listened. For decades, we sent robots to Mars, photographed Saturn's rings, even landed probes on comets. But Europa, that shining ball of ice next to Jupiter, always remained on the sidelines. We watched it from afar. We saw its scars. We guessed at what lay beneath its skin. But we never got close enough to knock on the door. Until today. Forget science fiction. Look at the calendar. It is late 2025. Right at this second, while you are listening to my voice, millions of kilometers from Earth, in absolute ringing silence and cold, an object is flying. It is not an alien ship. It is our creation. 6 tons of aluminum, titanium, gold foil, and silicon. Its wingspan is larger than a basketball court. Its sensors are more sensitive than a bloodhound's nose. Its name is Europa Clipper, and it has one goal: to break the prohibition. In October 2024, when the Falcon heavy engines tore through the sky over Florida, we launched more than just another scientific laboratory. We launched a time machine designed to answer the ultimate question of our existence. The timer is already ticking. If the calculations are correct, in 1,952 days, we might get an answer that changes everything. Religion, philosophy, biology, all our textbooks could become obsolete overnight. But why Europa? Why not Mars, where we are already crawling with rovers? Why not distant exoplanets? Because Europa is an anomaly. It is an error in the equation. By all laws of logic, it should be a dead, frozen piece of rock. It is so far from the sun that the light there is 25 times dimmer than on Earth. Eternal cold reigns there at -170 degrees. There is no atmosphere to breathe. And yet, NASA scientists are betting their careers, billions of dollars, and years of their lives that right there, in this icy hell, we will find life. Not bacteria fossilized billions of years ago, but living organisms, right now, swimming, eating, reproducing. We are used to thinking that life requires warm sunshine and green grass, but Europa Clipper is flying to prove us wrong. To prove that we were looking in the wrong place, that the universe is full of life, but this life hides in the dark. However, there is a reason Arthur C. Clarke wrote his warning. There is a reason we hesitated to go there for so long. It's not just the distance, it's exactly where Europa is located. It orbits inside the most dangerous place in the solar system, with the exception of the surface of the sun itself. We are sending our most expensive and complex ship into a trap, into a radiation meat grinder capable of killing a human in minutes, even if they were wearing a spacesuit. We are flying into the mouth of the beast. And to understand why this mission is true madness and the greatest risk in the history of unmanned spaceflight, we first need to look at Europa's master, Jupiter. When you look at photos of Jupiter, you see beautiful bands of clouds, orange, white, brown swirls, the famous Great Red Spot. It looks majestic and calm, like an oil painting. But that is a lie. If our eyes could see the invisible, if we could perceive magnetic fields, Jupiter wouldn't look like a planet. It would look like a pulsating monster taking up half the night sky. Jupiter's magnetic field is the most powerful in the solar system. It is 20,000 times stronger than Earth's. Its tail stretches all the way to Saturn. And inside this magnetic bubble, physics is committing violence against matter. Jupiter works like a giant particle accelerator. It captures electrons and ions, accelerates them almost to the speed of light, and locks them in a deadly trap around itself. It's like the Van Allen radiation belts around Earth, but on steroids and filled with rage. Europa orbits right inside this hell. Imagine standing in a shower, but instead of water, acid is pouring down on you. That is roughly what the environment around Europa looks like for any machinery. It is not just the vacuum of space, it is a storm of high-energy charged particles. They don't just hit the ship's hull, they pass through it. They punch through microchips, flip zeros to ones in the code, burn out pixels on cameras, and destroy the structure of materials at the atomic level. For NASA engineers, this is a nightmare. Sending a complex computer to the most radioactive place in the system is like putting a working laptop in a microwave and turning it on full power. Sooner or later, the electronics will fry. The only question is, will we have time to transmit the data before the probe's brain turns into a useless silicon brick? That is why the mission is so difficult. We cannot simply enter orbit around Europa and fly there for years, as we do at Mars. Orbiting Europa is a death sentence. The probe would burn out in a couple of months. Therefore, Europa Clipper will make dives. It will fly in close, collect data, and immediately fly away, out to a safe distance, to catch its breath and transmit information to Earth. But let's leave the robots aside. Let's talk about us. About fragile bags of water and bones. Movies often show heroes walking on the surface of icy moons, looking up at giant Jupiter in the sky. It's romantic. But here is what would actually happen if you teleported to the surface of Europa right now. Without tons of lead shielding. Just in a spacesuit. You wouldn't die from the cold, and not from suffocation. Death would come invisibly and almost instantly. The radiation level on Europa's surface is about 540 rem per day. For reference, 500 rem is a lethal dose for a human. You wouldn't need to spend days there. Minutes would be enough to start irreversible processes. You would taste metal in your mouth. That's the ionization of the air inside your helmet and the breakdown of your saliva. Your eyes, even when closed, would see bright flashes. This is the Cherenkov effect. High-energy particles punching through your eyeballs and optic nerves, causing a glow inside your head. Your DNA would begin to fall apart right inside your cells. This isn't the kind of radiation that causes cancer in 20 years. This is acute radiation sickness. Your nervous system would fail first. Nausea, disorientation, coma. You would be dead long before you ran out of oxygen. Jupiter sterilizes everything it touches. It unleashes such a torrent of energy onto Europa that the moon's surface itself glows in the dark. We recently learned this. Europa's ice fluoresces. It shines with a ghostly green or blue light due to the constant bombardment. It is a beautiful but absolutely dead place. On top. And here arises the main paradox. The most hostile environment in the solar system hides within itself the most favorable cradle for life. The radiation that kills everything on the surface cannot penetrate deep down. Ice saves. Ice is a shield. Beneath this radioactive glowing shell lies a world that hasn't seen sunlight for billions of years. And to understand it, we need to look at the scars covering the face of this moon. If you fly up to Europa at a safe distance, the first thing that catches your eye is its unnatural smoothness. There is a rule in the solar system. The older the object, the worse it looks. Look at our moon, at Mercury, or at Europa's neighbor, Callisto. They are beaten. They are covered in thousands of craters, large and small. Every meteorite that fell over 4 billion years left its mark. It is a history of violence recorded in stone. But Europa looks like it was born yesterday. It is the smoothest object in the entire known universe. If we shrunk Europa to the size of a billiard ball, it would be even smoother than a ball bought in a store. There are almost no mountains. There are almost no craters. The highest peaks reach only a couple of 100 meters. For comparison, on Earth, elevation changes are measured in kilometers. Why? Where did the craters go? Do meteorites miraculously bypass Europa? No, meteorites hit it just as often. The secret is that Europa knows how to heal its wounds. Its surface is not dead stone. It is a dynamic, constantly changing ice crust. Scientists estimate Europa's surface is only 40 to 90 million years old. In geological terms, this is infancy. This means something is erasing the old and creating the new. Something is constantly renovating this icy facade. Look at those famous streaks that score the entire globe. They look like a chaotic ball of yarn or cracks on an old vase. Scientists call them lineae. From orbit, they look painted with a brush. Red, brown, reddish lines on a white-blue background. For a long time, we didn't understand what they were. Now we know they are tension cracks. Europa's ice shell is bursting. Two giant plates of ice spread apart, and from below, from the warm depths, water or soft ice rises. It fills the crack, freezes, and glues the rupture shut. And that strange rusty color? That's not the color of ice. It is likely salts and minerals, sulfates, magnesium, perhaps simple table salt. They rise from the depths with the water. And when they hit the surface, that deadly Jupiter radiation we talked about comes into play. It chemically alters these salts, literally frying them, giving them that characteristic rusty hue. Essentially, we are seeing the contents of the ocean splashed out and dried by radiation. We are seeing the taste of this ocean without even tasting it. But there are places on Europa even stranger. Astronomers call them chaos. For example, Connemara chaos. Imagine a giant puzzle that someone assembled, then angrily slammed their fist on the table, shuffled the pieces, flipped some of them over, and then poured glue over the whole thing. That is exactly what Connemara chaos looks like. It is a jumble of ice blocks, icebergs the size of cities, that seem frozen into a new, smoother surface. This could only happen one way. The ice melted. The solid surface became liquid or slushy. The icebergs floated, drifted, rotated, and then suddenly froze again. All these clues, the lack of craters, the scar cracks, the chaos zones, are screaming one fact at us. Europa's ice is not sitting on solid rock. It is floating. It is sliding. It rotates slightly faster than the Moon's internal core. This means there is no friction holding it down. There is lubricant, a global, deep, liquid layer. But here physics trips us up. Europa is 5 times farther from the Sun than Earth. It is freezing cold there. Water should be as hard as granite. Where does the energy come from to melt this ice? Where does the heat come from in this cosmic refrigerator? The answer lies not in the sun, and not in radiation. The answer lies in a dance. A brutal gravitational dance that Europa performs with her brothers and sisters. To understand why Europa is alive, we need to forget about space for a minute and come down to Earth. Go to your kitchen. Take a regular metal spoon or a wire hanger. Now start bending it back and forth quickly. Back and forth, again and again. Do this about 20 times. Now, immediately touch the bend to your lips or your wrist. You will feel a burn. The metal has become hot. This is friction. When you deform a material, layers of atoms rub against each other, and the mechanical energy of your movement turns into heat. It's simple physics. Now imagine that instead of a spoon, you have an entire moon the size of our Earth's moon. And instead of your hands, you have the gravity of the largest planet in the solar system. Jupiter doesn't just keep Europa in orbit, it engages in gravitational violence. But it doesn't do it alone. Europa has accomplices, other moons, Io and Ganymede. They are in what is called an orbital resonance. For every 4 orbits of Io, there are 2 orbits of Europa and 1 orbit of Ganymede. This cosmic rhythm works like a swing. Every time the moons get close, they yank on each other with gravity. Because of this, Europa's orbit is not a perfect circle. It is elongated, like an egg. And this is a death sentence for a quiet life. When Europa gets closer to Jupiter, the giant's monstrous gravity grabs it and stretches it toward the planet. The very shape of the moon changes. It flattens. But a day and a half later, Europa flies to the far point of its orbit, where the grip loosens and the moon springs back, restoring its spherical shape. This cycle repeats every 3.5 days. Squeeze, release, squeeze, release. We are not talking about centimeters. The surface of Europa, this hard frozen ice, heaves and falls by 30 meters. Imagine a 10-story building that drops out from under your feet every 3 days, then grows back. The whole moon groans. Its rock core rubs against the mantle. Its ice crust cracks. Billions of tons of rock and ice rub against each other in an endless cycle. And like that spoon in your kitchen, Europa heats up. It doesn't need the sun. Jupiter's gravity pumps colossal amounts of energy directly into it as heat. This heat is born in the rock core and rises up. It meets the ice shell from below, and the inevitable happens. The ice begins to melt. This explains everything. This explains why Europa hasn't frozen to the core in 4 billion years. This explains the chaos on the surface. But most importantly, it means that beneath the ice crust, hidden from sight, lies a layer of liquid water. And when we say layer, we are being modest. We are used to being proud of our oceans on Earth. The Pacific, Atlantic, Indian, they seem bottomless to us. But compared to what sloshes inside Europa, Earth's oceans are just a puddle after rain. What we have found in calculations of this water's volume forces us to rethink the very concept of a water world. Let's conduct a thought experiment. If you took the Earth and squeezed it like a wet sponge, collecting all the water, all the oceans, rivers, Antarctic glaciers, clouds, and even the water in your cells, into one drop, that drop would be about 1,400 kilometers in diameter. That seems like a lot. But if you did the same with Europa, which is itself 4 times smaller than Earth, its water drop would be larger than ours, twice as large in volume. We call Earth the blue planet, but that is marketing. In reality, Earth is a dry rock covered with the thinnest film of moisture. The average depth of the world ocean is only 4 kilometers. The deepest point, the Mariana Trench, is 11 kilometers. For a planet 13,000 kilometers in diameter, that is nothing. It's like condensation on an apple. Europa is built differently. Beneath the ice crust, which varies from 10 to 30 kilometers thick, the water begins. And it doesn't end after 4 kilometers, or after 11. According to modern models, the depth of Europa's ocean is between 60 and 150 kilometers. Try to comprehend this abyss. 100 kilometers vertically down. That is 10 Mariana Trenches stacked on top of each other. This is a world where the concept of bottom lies somewhere beyond human imagination. But how do we know this for sure? We haven't drilled the ice. We haven't lowered cameras. Maybe it's just the fantasies of theorists? No, we have proof. And it didn't come from cameras, but from a magnetometer. In the 90s, the Galileo probe flew past Europa and noticed something strange. Jupiter's magnetic field around the moon was distorted. It wasn't behaving the way it should around a piece of dead rock. Something inside Europa was reacting to the giant's magnetic field. Something was creating a counterfield, working like a giant electrical conductor. In nature, there aren't many materials capable of conducting electricity on a planetary scale. It could be liquid iron, like in Earth's core. But Europa is too small for such a core. The only substance that fit the Galileo data perfectly was salty water. Salty water is an excellent conductor, and the data showed that this conductor doesn't lie in separate lakes. It envelops the entire moon. A global enclosed ocean. This changes everything. This means that beneath us is not just water. It is a stable environment that has existed for billions of years. Imagine diving in there. You pass through kilometers of ice. The light gets dimmer until it disappears completely. You enter absolutely black water. There is no day or night here, no seasons. Here reigns eternal pressure that would crush a nuclear submarine like a soda can. It seems like a dead place, a cold, dark prison. But it is here, in this darkness, that magic happens. Europa's ocean doesn't hang in a void. Above, it is capped by ice, but below it touches the rocky mantle, hot rocks, water and stone. This might seem like a minor detail, so it touches. But for astrobiologists, this is the holy grail. The contact of liquid water with a hot silicate floor is exactly where chemistry turns into biology. This is the kitchen where the ingredients of life are cooked. And if our theories are correct, the bottom of Europa's ocean doesn't look like a desert. It looks like a fireworks display. But water alone is not enough. If you pour distilled water into a sterile flask and leave it for 1 billion years, life will not emerge. It will just be a wet void. Life needs soup. It needs broth. Biologists call this the Chenop's list: carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. These are the Lego bricks from which every molecule of your body is assembled, from DNA to proteins in your muscles. Without this set, the magic won't work. Are these elements on Europa? Absolutely. Comets and asteroids bombarded it at the dawn of time, delivering organics. But just having ingredients on the shelf isn't enough. Someone has to mix them and heat them up. And here we return to the bottom of Europa's ocean, to where the icy water meets the scorching stone. In 1977, oceanographers on Earth made a discovery that shocked the scientific world. They lowered a submersible to the bottom of the Pacific Ocean, near the Galapagos Islands. They expected to see a desert. There was no light, the pressure was monstrous, the water temperature was near freezing. By all biological rules, it should have been empty. But when the spotlights cut through the darkness, scientists saw not a desert, they saw an oasis. Giant 2-meter worms with bright red tips, white crabs, mollusks, shrimp. Life teemed around strange stone chimneys spewing black smoke. These were hydrothermal vents, black smokers. Water seeped into cracks in the crust, was heated by magma, saturated with minerals, and shot back into the ocean. And bacteria learned to use this chemistry. They didn't care about the sun. They didn't need photosynthesis. They invented chemosynthesis. They ate the energy of the planet itself. We don't need sunlight. On Earth, there are entire ecosystems that have never seen the sun. And they don't just survive, they rule the abyss. If this works on Earth, why can't it work on Europa? We are practically certain that Europa's floor is littered with similar smokers. The tidal heating that melts the ice must do the same to the mantle. There must be volcanoes. There must be geysers. But Europa has prepared another surprise for us. Remember that deadly radiation on the surface? The one that kills everything living? It turns out it might be a savior for those below. Jupiter's radiation hits the ice on the surface and splits water molecules into hydrogen and oxygen. Hydrogen escapes into space. It is light, but oxygen remains. It accumulates in the ice crust. Europa slowly renews its skin. Ice plates slide over each other, sink, melt. And this process slowly, like a conveyor belt, delivers the accumulated oxygen from the surface directly into the depths of the ocean. This changes the game. Bacteria at the volcanoes don't strictly need oxygen. They can live without it. But if oxygen gets into the ocean, it opens doors for something bigger. Oxygen provides a lot of energy. It allows complex organisms to exist. Fish? Squid? We don't know. But the energy budget of Europa's ocean allows for supporting more than just microbes. We have water, we have heat, we have chemical elements, we possibly even have oxygen. This isn't just a chance, it is the perfect incubator. It would seem everything adds up. Europa is the perfect candidate. But there is one problem. There is another moon in the solar system. It is smaller, it is farther away, but it does what Europa is too shy to do. It screams about its life, shooting it straight into space. In science, there is a principle: always pick the low-hanging fruit. If you are looking for lost keys, look under the streetlight, not in the dark alley. And if we follow this logic, we made a mistake. We are flying to the wrong place. Meet Enceladus. It is a tiny moon of Saturn, only about the size of the United Kingdom. It is even farther from us than Europa. But Enceladus has one colossal advantage. It doesn't hide its secrets. It shouts them. In 2005, The Cassini probe flew up to Enceladus and saw something incredible. From the moon's south pole, from huge cracks poetically called tiger stripes, fountains are beating into space. This isn't just steam. These are geysers of water, ice, and organics shooting hundreds of kilometers up. Enceladus is so active that it created an entire ring around Saturn from its own ocean. Cassini didn't even have to land. It simply flew through this plume. It literally tasted Enceladus. And its sensors showed there is salt. There are silica nanoparticles that form only in hot water. There are simple organic molecules. Enceladus gives us samples of its ocean for free. We don't need to drill the ice. We don't need to guess. Just hold out a bucket. So why did NASA spend $5 billion on a mission to Europa, which is closed by a shell, instead of returning to the welcoming Enceladus? Why did we choose the hard way? The answer comes down to two words: time and scale. Enceladus is a dwarf. It is too small. Its gravity is negligible. Its ocean is likely young, and perhaps it will freeze soon. We don't know how long it has been active. Maybe the geysers turned on just 1 million years ago and will turn off tomorrow. It is a blip on the radar of history. Europa is a beast of a completely different weight class. It is the size of our moon. Its ocean has likely existed as long as the solar system itself, 4 billion years. This is not a temporary puddle. This is a stable biosphere on a planetary scale. Life on Europa had time. Billions of years for evolution. Billions of years to go from the simplest cell to something more interesting. And the second difference: energy. Remember that oxygen Jupiter's radiation hammers into Europa's ice. Enceladus doesn't have such a powerful neighbor. Saturn is calmer. Enceladus doesn't have that influx of oxidizers from above. Enceladus's biosphere, if it exists, is likely starving. It is limited. It lives on meager rations. Europa's biosphere, thanks to Jupiter's radioactive gift and powerful tidal heating, could be energy-rich. There is fuel not just for bacteria, but perhaps for multicellular organisms. It is a bet. We bet on Europa because if we find life there, it will mean that life is not an accident, but a regularity for large, stable worlds. Enceladus might just be a weird exception. Europa is the rule. We chose the harder target. We chose the locked door. But the prize behind that door could be much bigger than just microbes. But to knock on this door, we needed a tool of a special kind. A regular satellite wouldn't survive there for a week. We needed a ship that looks more like an armored safe with wings than a science station. And engineers had to perform a real miracle to make it fly. Usually, when we imagine space probes, we think of small boxes the size of a fridge studded with antennas. Voyagers, pioneers, they were compact. Europa Clipper is not a box. It is a Leviathan. If you put it on a basketball court, its solar panels would hang over both hoops. Its wingspan is over 30 meters. It is the largest interplanetary ship NASA has ever built for a planetary mission. Why is it so huge? It's all about the light. Jupiter is 778 million kilometers from the Sun. The light there is so weak that the Sun looks not like a blazing disk, but just like a very bright star. If you put a standard solar panel from your roof there, it wouldn't generate enough energy to even light a bulb. Therefore, Europa Clipper is essentially one giant flying solar power plant. It needs to catch every photon to power its 9 ravenous scientific instruments. But size isn't its most important feature. The main thing is in the center. How do you protect delicate microchips from radiation that melts metal? Lead? It's too heavy. If we shielded the whole ship with lead, it wouldn't even lift off the launch pad. NASA engineers found a brilliant solution. They didn't shield the whole ship. Sensors, antennas, motors, they have to be outside, exposed. But the brains, the onboard computer, memory blocks, power management systems, they hid. They created what they call the vault. The engineers didn't invent a force field from science fiction. They made something cruder but reliable. They built a tank. In the very heart of the ship is a box with walls of titanium and aluminum almost a centimeter thick. That seems like a little, but by space standards, it is impenetrable armor. This box weighs 150 kilograms. And inside it, cramped, shoulder to shoulder, sit all the vital systems of the ship. This is their bunker. Outside, a radiation storm rages, but inside the vault, radiation levels are reduced to acceptable limits. Not to zero, of course. The ship will still take its dose, but the armor will give it enough time to complete the mission before the electronics start to die. It is a race against death built into the design itself. Clipper is not designed for eternal life. It is a kamikaze whose goal is to last exactly as long as necessary. And that's not the only problem. In space, there is no air to cool machinery, and electronics get hot. Usually, heat is just radiated into space, but the vault is sealed. If nothing is done, the computer will cook inside its own armor. So engineers came up with a system of pipes with fluid circulating through the armor, taking heat from the processors and dumping it to an external radiator. It looks like a circulatory system. Europa Clipper is a warm-blooded robot. It is ready. It has energy, it has armor. But most importantly, it has senses. To find life without landing, this ship must be able to do what no human can. It must be able to see through ice and smell the vacuum. So, we locked the computer in a safe, hung solar panels on it, and sent it to Jupiter. But the main question remains, how on earth will we know someone is living under the ice if we don't even land on the surface? We aren't drilling the ice. We aren't lowering a submarine. We are just flying by. Can you perform a biopsy on a patient just by walking past them in the hallway? Turns out you can. If the patient is bleeding openly, Europa is not hermetic. We already talked about geysers. Even if they don't erupt as powerfully as on Enceladus, Europa is constantly sweating. Micrometeorites hit the ice, kicking up dust. Radiation burns off molecules. All this creates a thin, almost ghostly atmosphere around the moon. And Europa Clipper is flying there not to look. It is flying there to smell. On board is an instrument with the daunting name MassSpex. It is a mass spectrometer. Think of it as a super-sensitive electronic tongue. When the probe flies through clouds of vapor or dust above Europa, it will open a shutter. Gas molecules will fly inside the device, and there, inside, magnetic fields will sort them by weight. MassSpex is a monster of precision. Previous generation instruments, like those on Cassini, could say, okay, this is water and this is carbon. MassSpex goes much further. It can see the difference between nearly identical molecules. It can assemble a whole story from atoms. What is it looking for? It is looking for complex organic chains, fatty acids, amino acids. But most importantly, it is looking for patterns. In chemistry, there is a rule. If you mix chemicals in a test tube randomly, you get chaos. Different molecule lengths, different types. But life is order. Life loves specific numbers. Life builds its cells from very specific bricks. If MassSpec sees that there are suspiciously many specific amino acids and none of others, that is a biosignature. That is the chemical fingerprint of life. This is the most precise nose we have ever sent into space. It is capable of finding a concentration of a substance equal to 1 drop of ink in an Olympic swimming pool. But smelling the atmosphere is not enough. We need to look under the blanket. We need to see the ocean itself. For this, Clipper has eyes that see through walls. The Reason instrument. This is an ice-penetrating radar. On Earth, we use similar technology to look for lost cities and jungles or study Antarctic glaciers. Reason sends a powerful radio pulse down. These waves pass through the vacuum, hit the ice, and go further, deep down. But when a radio wave meets water, it reflects back. Clipper will scan Europa layer by layer, like a doctor giving a patient an MRI. We will see not just the surface, we will see the structure of the ice down to a depth of 30 kilometers. We will see cracks. We will see pockets of liquid water trapped inside the ice, so-called lenses. It is in these pockets, like incubators, that life might thrive, even without reaching the main ocean. And finally, the eThemis thermal imager. It will look for hotspots. On Earth, if you look at a frozen lake through a thermal imager, you see where the ice is thinnest. It's warmer there. eThemis will look for places where the warm ocean comes close to the surface. That is exactly where we will point the other instruments. This is a combined attack. The radar looks for water inside the ice. The thermal imager looks for breach points. Spectrometers taste what flies out. And high-definition cameras film it all with a resolution of 0.5 meter per pixel. We have never looked at an icy moon with such thoroughness. We will map Europa more accurately than some regions of Earth were mapped 100 years ago. But there is one nuance. All these instruments are useless until they reach the target. And the target is very far away. And the path to it is not a straight line. It is a complex game of cosmic billiards that lasts for years. In space, a straight line is not the shortest distance between 2 points. It is the shortest path to mission failure. If we aimed Europa Clipper straight at Jupiter, we would need a rocket the size of the Titanic, completely filled with fuel. To brake at such a massive planet, you need to burn an incredible amount of energy. We don't have such rockets, so engineers chose a different tactic. They decided to play cosmic billiards. They decided to steal energy from planets. This is called a gravity assist, or the slingshot effect. We launched Clipper in October 2024, but instead of flying to the outer solar system, it first flew to Mars. In February 2025, earlier this year, the probe swept past the red planet. It approached it, let Mars' gravity grab it, and then shot itself further, stealing a bit of orbital speed from the planet. For Mars, this loss is imperceptible. For the probe, it is a free boost. But that wasn't enough. Now, in late 2025, as we speak, Europa Clipper is in the deep void between the orbits of Mars and Earth. It is making a huge loop. And do you know where it is heading? Back home. In December 2026, the ship will return to Earth. It will fly past us on a skimming flight. That will be the last time it sees home. Earth's gravity will give it the final, most powerful kick, which will accelerate it to the necessary speed and throw it into the cold abyss of the outer solar system. This dance of planets takes years, 5.5 years of flight. Right now, while you are watching this video, it is flying millions of kilometers in complete silence, controlled only by mathematics. Around it, there is nothing but stars and the static electricity of the solar wind. It is the loneliest journey imaginable. The probe sleeps. Most of its instruments are turned off. Only the heartbeat works, a periodic signal to Earth. I am here. I am okay. Temperature normal. Operators at NASA's Jet Propulsion Laboratory listen to this beep, check telemetry, and wait again. It is a strange feeling. We built a machine for $5 billion. The best minds of humanity worked on it for decades. And now it just hangs in the void, falling slowly toward its goal. We can do nothing but wait. The entire journey will be 2.9 billion kilometers. This distance is impossible to comprehend. If you flew on a passenger plane without stopping, it would take you 300 years to cover this path. Clipper will do it by April 2030. And that is where the most interesting part begins. Arrival. It won't be a soft landing. It will be braking on the brink of catastrophe. The ship will have to fire its engines and burn fuel for hours so that Jupiter's gravity captures it but doesn't crush it. If the engine doesn't fire on time, the probe will simply fly by and disappear forever into deep space. There will be no second chance. But if everything goes successfully, the countdown begins. The timer we talked about at the very beginning, April 11, 2030. Mark this date on your calendar. On this day, silence will hang over the Jet Propulsion Laboratory in California. Hundreds of engineers will be staring at screens where telemetry graphs are frozen. No one will breathe. The signal from Jupiter takes about 50 minutes to reach Earth. This means that everything they see on the screens has already happened in the past. If the ship exploded during braking, it has been dead for an hour, but they still see it alive. These are the 7 minutes of terror we experienced landing Mars rovers, only stretched to an hour. On this day, Europa Clipper will fire its engines to enter Jupiter's orbit. If the engines work as planned, the main science phase begins. Why did I say 1952 days? That is exactly how much time will pass from launch until the moment we start receiving the first full-fledged scientific data from the lowest altitude. That is the price we pay for knowledge. 5.5 years of waiting. But when the data starts flowing, it will be like a dam breaking. The mission is designed for 4 years of active work. During this time, the probe will perform 49 flybys of Europa, and each flyby will be more aggressive than the last. At first, we will fly high, calibrating instruments. But then the orbit will lower. We will get closer and closer. We will fly over the surface at an altitude of just 25 kilometers. That is insanely low. That is the stratosphere. We will glide over ice peaks, almost touching them. Cameras will see the ice with such resolution that we will be able to distinguish objects the size of a car. We will see cracks in 4K. We will see places where water bursts out in real time. But the most important thing won't happen in photos. The most important thing will happen on the graphs of the mass spec spectrometer. Imagine this moment. The probe flies through a plume of vapor. The instrument captures molecules. The data is packed into packets and sent across millions of kilometers of void to Earth. A scientist opens a file. They see peaks on a graph. Here is the water peak, expected. Here is the salt peak, normal. Here is the carbon dioxide peak, good. And then they see something else, a complex pattern, a ratio of carbon, nitrogen, and hydrogen that cannot arise in dead chemistry. They see amino acids twisted in a specific direction. They see an imbalance that only a living cell consuming energy can create. It won't be a photo of a green man or a fish. It will just be a line on a computer screen. But this line will divide human history into before and after. We are not looking for intelligence. We do not expect Europa to send us a radio signal. We are looking for slime, bacteria, microscopic organisms clinging to life near hot vents in the dark. But if we find them, if we find even one dead bacterium or even just a chemical trace of its activity, it will mean that the universe is teeming with life. Because if life could emerge twice in one solar system, once on a warm rocky ball near the sun, and a second time in an icy hell near Jupiter, it means life is not a miracle. It means life is inevitable. It is simply a property of matter. And here we are. The ship is flying. The clock is ticking. We made our move. Now it's Europa's turn to show its cards. But are we ready for the answer? Are we ready to learn that we are not special? Or, what is even scarier, are we ready to learn that it is empty? Imagine we get the answer, yes. Imagine that in 2030, headlines on all news sites in the world explode. Life found. Not intelligent. Not green men with lasers, just microbes. Slime. Analogues of Earth bacteria swimming in a dark ocean 500 million kilometers away. In that moment, we will cease to be the center of creation. We will lose our uniqueness, but we will gain brothers. It will mean that biology is as universal a law of the universe as gravity. If there is water and heat, life is inevitable. It means that the Milky Way, with its hundreds of billions of stars, is not just full of rocks and gas. It is full of neighbors. We just haven't met them yet. The view of the night sky will change forever. You will no longer see a void. You will see a forest full of eyes. But imagine the other option. The answer, no. Clipper scans Europa year after year. Its instruments work perfectly. It finds water, it finds heat, it finds all the necessary elements. But the ocean is sterile, dead. That is much more frightening. It would mean that the emergence of life on Earth is not a rule. It is a monstrous, incredible statistical anomaly. Winning the lottery with a chance of 1 in a trillion trillion. It would mean that we are orphans, that in this entire infinite black abyss, among trillions of galaxies, we are the only spark of consciousness. If Europa's ocean is empty, then the responsibility lying on humanity becomes unbearably heavy. We are the sole guardians of life. If we destroy ourselves, if we burn our planet in nuclear fire or ecological catastrophe, the universe will become dead again, and perhaps forever. The silence of space will become even louder. Whatever answer we get, it will change us. Ignorance is comfort. Knowledge is a burden. But we are humans. We don't know how to sit in comfort. We need to know what is over the horizon. Right now, in these minutes, Europa Clipper is flying through the darkness, between Mars and Earth, a small point of light in the infinite void. Engraved on its side is a poem by American poet Ada Limon. It is dedicated to water, and there are these lines: "We, made of water, yearn for water." This is not just a scientific mission, it is a message in a bottle. We are throwing it into the cosmic ocean, not to ask for help, but simply to ask, is anyone else here? 1,952 days, or a little more, or a little less. The clock is ticking. Arthur C. Clarke wrote, "All these worlds are yours, except Europa. Attempt no landing there." We are not landing, we are just watching. We have stepped up to the forbidden line, pressed our nose against the glass, and are peering into the darkness. And soon, very soon, the darkness will look back at us. Stay curious and look at the stars.